Hey everybody. Today we're doing a few more integrals that involve partial fractions. Here are the three problems we're going to do. Let's jump right in with the first one. Integral of 3x plus 1 over x cubed plus 9x. Whenever we see a rational expression, one polynomial divided by another, that can't be done with a simple u substitution or integration formula, we want to think in terms of partial fractions. We factor the denominator all the way. Here, it's just x times x squared plus 9. Notice, by the way, that the x squared plus 9 cannot be factored any further. It's irreducible. Then, we do the partial fractions decomposition. Here, we have a linear term x, so we get an a over x. And we have an irreducible quadratic term, x squared plus 9. That gives us the bx plus c over x squared plus 9. We get a common denominator. And since the denominators are now the same on the left and right, the numerators have to be equal. Foiling out the right, I recognize that I have two polynomials that are the same. 3x plus 1 equals ax squared plus 9a plus bx squared plus cx. And the only way that can happen is if the x squared terms match up on the left and right, if the x terms match up, and the constant terms match up. Using that fact, I get a as a ninth, c is 3, and b is negative a ninth. Overall, the decomposition looks like this. 1/9 over x plus negative a ninth x plus 3 over x squared plus 9. So to do this integral, I'm just going to integrate that last expression. This thing. I'm going to do this with three separate integrals. Notice I'm also factoring out the constants. I've broken up the term inside the integral with the x squared plus 9 in the denominator into two separate integrals, and that's generally the way you want to do this. The reason is that middle integral can be done with a u substitution, and the far right integral can be done as an arctangent. The first integral of the three is just the natural log of the absolute value of x. The second will be 1/18th natural log of x squared plus 9. We get that using the u substitution, u equals x squared plus 9. Finally, the last integral, as I said, will be an arctangent. I need it to be in the form of 1 over something squared plus 1. So I factored 9 out of the denominator to get it in that form. Now, the u substitution, u equals x over 3, will get the job done on that last integral. Overall, I get 1/9 natural log of the absolute value of x, minus 1/18th natural log of x squared plus 9, plus the arctangent of x over 3, plus c. Problem 2. Integrate x minus 2 over 2x minus 1 squared times x minus 1. Here, the denominator is all linear factors, but one of them is repeated. I have 2x minus 1 times 2x minus 1. So the partial fractions decomposition is going to have this form. A constant over each linear term, and when I have linear terms squared, I need two terms for that. So a over 2x minus 1 plus b over 2x minus 1 quantity squared plus c over x minus 1. As before, I get a common denominator and equate the numerators. Now, in this case, there are some convenient values to plug in. For example, when I plug in x equals 1/2, the a and c terms go away. I'm just left with the b term. Negative 3/2 equals b times negative 1/2, or b equals 3. Similarly, if I plug in x equals 1, then the a and b terms go away, and I'm just left with the c term. I get c equals negative 1. Now, to solve for a, we're actually going to have to FOIL out and use the fact that the like terms have to match up on the left and right. Here's what I get when I just equate the left and right with b equals 3 and c equals negative 1. And then when I FOIL out, matching up the like terms, I get a equals 2. Overall, here's my partial fractions decomposition. 2 over 2x minus 1 plus 3 over 2x minus 1 squared plus negative 1 over x minus 1. So to integrate this big expression on the left, I want to integrate each of the three smaller expressions on the right, each of which is fairly direct. I get the natural log of the absolute value of 2x minus 1 minus 3/2 2x minus 1 to the negative first, minus the natural log of x minus 1 in absolute value, plus c. Problem 3. Integral 1 over 2 root x plus 3 plus x. So this looks like a different problem at first glance. It's got radicals. It's not a rational expression. However, the u substitution, u equals square root of x plus 3, will transform it into a rational expression. How do I know to do this u substitution? Well, I'm really just following my nose. I don't know really what else I could try other than this. So I'm going to try it, see where it takes me, and then hope that I get to a place where I have an integral that I know how to handle. Once I've chosen u equal the square root of x plus 3, I differentiate both sides and solve for dx. dx is 2 times the quantity x plus 3 to the 1/2 du. So 2 root x plus 3 du. Substituting back in, I get this. Now, I can't integrate this right away. I can't integrate when I have two variables in my indefinite integral. I want to get the rest of those x's out. Now, part of it here is easy. I have the x plus 3 to the 1/2. That's the square root of x plus 3. That's just u. To get the other x out, the one in the denominator, 2u plus x, I want to take my u substitution, u equal the square root of x plus 3, and solve it for x. I square both sides, I subtract 3, and I get x is u squared minus 3. Completing the substitution, I get this integral, 2u over 2u plus u squared minus 3 du. Now my integral is just in terms of u, and it's something that I can integrate. It's now a rational expression. It's going to be a good candidate for partial fractions. Integral of 2u over u squared plus 2u minus 3 is the same thing as the integral of 2u over u plus 3 times u minus 1, just factoring the denominator. Now I do partial fractions on that rational expression. The denominator is just the product of two linear terms, so the form that I want is a over u plus 3 plus b over u minus 1. As before, I get common denominator, equate the numerators, and solve for a and b. Here, there are convenient u values to plug in. When u is 1, the a term goes away, and I get b as a half. And when u is negative 3, the b term goes away, and I just get a equals 3/2. So overall, the thing I'm trying to integrate is just 3/2 over u plus 3 plus 1/2 over u minus 1. So let's carry out this integral. Here I'm going to do this as two separate integrals. 3/2 integral 1 over u plus 3 du, and 1/2 integral 1 over u minus 1 du. Overall, I get 3/2 natural log of the absolute value of u plus 3 plus 1/2 natural log of the absolute value of u minus 1 plus c. Taking out the u and replacing it with what it's equal to, the square root of x plus 3, I get my final answer. If I cared to, I might be able to simplify this a little bit using some log rules to try and write this as a single log, but I think this format that we have here is already good enough.